Hello, everyone. Welcome to the implementation series for the year 2023. We're all set to kick it off today with the first session by none other than Greg Gifford. I'm so excited to hear from him today. And as you all know, Greg needs no introduction, so I will let him take it further. But before that, I have a few slides to share about the upcoming events. Let me quickly share what's coming up next in this series. So today's topic is all about the query and script timeouts. Greg is going to share how we can work around those timeouts and also some optimization tips. And we have a few upcoming sessions in the implementation series which are planned. That is about writing tracking data back to the Salesforce from Marketing Cloud. That is on 25th of January, and setting up better marketing campaigns and advanced use cases by Asia. That's on March 1st, and Marketing Cloud integrations and best practices by Kunal. These are all upcoming sessions, and you can register to these sessions on the Trailblazer community group, Phoenix in the group's link. And today's session is going to be recorded. And if you have any questions, post them in the chat window, and we will address those questions at the end of the session. And any questions after the session, feel free to post them on the Slack channel. And if you would like to share the feedback on today's session or any other comments, please share them on Twitter using the hashtag MCLearningCamp, Phoenix B2C UG, and Marketing Champions hashtag. And with that, I will turn it over to you, Greg.
Hello all, so happy to be here. Today I'm going to be going over a topic that can make or break a project, which is workarounds for query and script timeouts. Now, some of you guys may be thinking, who the hell is this guy and why should I listen to him? To which I say, fair point. So to help introduce myself, I wanted to share a few of my proudest achievements in relation to Marketing Cloud and Salesforce in general, as well as some background in my career. As you can see, currently I am a Senior Director in Salesforce Marketing Cloud Engineering at Merkle/Dentsu. I recently wrote a book, Automating Salesforce Marketing Cloud. I'm a current Salesforce MVP and Marketing Champion. I am the owner and author of my own Marketing Cloud-focused blog, GordTunnington.com. I am a founder and admin for HowToSFMC.com. I am a top contributor in Salesforce Stack Exchange under the Marketing Cloud aspect, and also a Trailblazer community group, and am a speaker and subject matter expert for Marketing Cloud. Just to get the basics and get us all on the same page, I wanted to share some quick limitations on each of the activities as to what could cause a failure for them or cause inefficiencies that could create extra processing. Previously, Salesforce was able to push that 30-minute limit out, but as of the past year or so, I know they've gotten very strict on that and mostly deny pretty much every single request unless you have a crazy business case. But I've seen really good cases be denied on that. And honestly, I mean, this is true on both just the server-side JavaScript script activity as well as the SQL query. So it really is best to try and work within that 30-minute timeout as if that was the be-all, end-all, and not try to rely on that getting pushed out for you. That being said, with the purpose of Marketing Cloud not being ETL or scripting or anything like that, it's a messaging platform, the 30-minute window should be an appropriate length for the vast majority of tasks you'd want to place inside of an automation. Going beyond that potentially could mean you should instead look at utilizing another system or process that would better handle and is built for those types of things. So now that we have that baseline, I wanted to jump into our first workaround topic, which is the Salesforce Marketing Cloud SQL query activities. So before really getting into the example workarounds, I wanted to first hit up on some query optimizations to potentially make your queries more efficient and effective and possibly remove the timeout error altogether and make most of that not needed. First rule for a performant query is to only include the rows and columns you need. The more you reduce the size and scope, the better the query will run. This can be done through strict conditions inside of where clauses, only including the fields you need in the select statement, reducing the query data extension and output data extension fields to only those you need, so on. Then next, there's the limit the usage of joins as much as possible. The less joins you have, the less data that is needed to be retrieved and interacted with, meaning that the query can run quicker. Reducing the need for multiple joins can greatly increase the efficiency of your query. Then there's utilizing staging data extensions instead of the data views. This one can create a huge improvement with little effort. By utilizing a data extension with proper primary keys instead of using the data views, you can see a much higher efficiency. This is because the data views are not indexed, so they take up the significant amount of extra processing comparatively when using them. So as long as your use case allows you to do this, I would highly recommend making your own DEs to house your data view data. Then there's keeping your where clauses sargeable. Now, I've seen that thrown around a bunch of places, and I admit when I first saw it for a while, I was like, what the heck does that mean? Like, it sounds like it's like some sort of military title of some sort. So I went and I dug into and figured it out, but there is a long technical definition to go along with it, but I'm going to kind of break it down to a simpler definition where Sarge, S-A-R-G, is search arguments, which is S and then ARG from arguments. And then to explain it, when it is sargeable, it means that these arguments can be resolved by the storage engine through direct interaction with the table or the index, basically meaning it does not need to process it beyond the initial retrieve from the source. Now, to hit that, usually it means on the comparison, the one you're doing from the left side of the operator. So for instance, let's say it's field A equals 3. Keeping field A from having things like upper or lower or having like a date at or format to it, removing all that will make it sargeable. So if you're just comparing the raw pull from the data source, that is much easier and requires much less processing for it to do that comparison than if you were to include it. Then next is to utilize your primary keys as much as possible as foreign keys, which is comparison between relational tables and or conditional comparisons and where statements, etc. Primary keys are by default indexed, meaning that utilizing them in this way will result in a more performant query than utilizing other fields. Now, I know I barely scratched the surface here, and honestly, I could create a whole 1-hour presentation on just this and still not fully cover it, but we do need to move to the workarounds. So the first workaround is really just a single idea, splitting your query into multiple queries. Now, the part that gets interesting is all the ways you can do it. So first one is using the custom object key. Honestly, for breaking apart SQL queries, this is usually the best one to assist with timeouts. It tends to be the most performant, especially at high volume. That being said, this is not the one that I would go to as the be-all solution either. There are times that the other solutions are better off and more performant or better fit for your use case. So first I'm going to go over custom object key is an internally used number identifier, usually hidden from view inside the UI. It's mostly used internally inside of Marketing Cloud to recognize each individual row inside of the row sets of the data extension. Utilizing this number identifier with the mod function, we can separate it out based on the remainders. Mod is equivalent to using the percent inside your formula. So for example, as you can see, using the mod function is equal to using the number, then the percent sign, and then the divider. You can then use the remainder numbers to separate out the return records into groups. So here's a quick example of that code. You can see it starts out, and then we have where custom object key %20, so it's breaking into groups of 20. And then this is a remainder of 0, and then we go all the way through. And then you'll see down here in the bottom one, it's now where it's 19. So this would be group 1, all the way down, this would be group 20, because it's starting from a 0 index. All right, next one are numerical splits. So for this, I included 2. There's rank and total, and then there's end tile. I've kind of grouped them together because they tend to follow the same general pattern. They just use a different method. One is quite a bit more math heavy than the other, but in general, both create a group ID field or equation for us to be able to pull sections or groups from the staging data, reducing the load of the individual query. So rank and total is utilizing the rank function along with count. Count is being used to grab the total of the specific pull to the data source. Then we use rank to help separate that out into different subsections. And then this will create either a staging query to create group numbers for separations of run, or potentially you can push this back to the source data extension and have a field in there denoting that number there. And then end tile is something that honestly it's much easier to use than the rank and total. It's a function by itself. You just do end tile and then put the number of groups inside of the parenthesis, and it'll start spitting those out, assigning a number within the range you set to quickly create group numbers. So here is rank and total query 1. As you can see here, this is pulling the rank on the 5th field down in the select statement over then order by new ID. So it's randomizing it. This is the first query to create the group numbers. It's recommended to only put in like primary keys and then the rank column and total column. It may also be good to add to the source D, like I had mentioned. But this sets it up. It'll pull all of the fields you need, as well as the rank number here, and then the total as the count number here. And I know I used an outer apply and got kind of fancy there, but it was an easy way for me to add this in without having to do the group by or anything like that. I could handle all that from the outer apply. Next is the second query. So this one is to segment out the data from the master based on the numbers from query 1. This will pull each section from master based on percentages. For example, for instance, in this example, we have RN, which is the rank number, is less than the total times 0.5, which is 5%. So it's pulling just the first 5% of the total to fill in and use that as an individual group, and you use that across each. See how this would be between the 6th and the 10th percentile, and it continues on to grow, and that will separate it out for you. This one is very powerful and very accurate, but as you can see, there is a lot of math involved. It's not as heavy processing as it looks, but it will be a bit heavy inside of different areas. So yeah, it's very accurate though, and especially if you want to do groups inside of groups, this is the way to go, because you can then partition the rank and get different group totals and counts and things like that, and it's very powerful in that way. But again, use with caution, because this isn't exactly the purpose of marketing clouds, that you can fall in a hole and start doing all these awesome crazy things and kind of push the limits of the system beyond where it should go. But yeah, all right, next up is end tile. So this is query 1. It's very similar to the last one, except this time we're using the end tile function with, and I put 8, so it's a group of 8, or I'm sorry, 8 different groups. And then order by new ID, which I believe I had in the last one as well, just is basically randomizing them so that it's a random grouping instead of by specific. If you want to make it specific, you can change the, you can change the new ID to a specific field inside of it. This again, recommended only to put the primary keys into the staging place so it's an easy comparison, or it may be best to add column to the source DE to pull. Then the second query is just basically adding the where clause and then the group field that we had set up from there, and then equals 1, 2, 3, 4, etc., all the way down to 8. And then each of these would be an individual query, pulling out specific sections of the master. You can have it where each one targets the same data extension, so you get all of the information across, or however you want to work that. But this will separate out the query to multiple queries and reduce the processing to get that overall timeout limit reduced. All right, so next are the split into multiple queries using top. So top, I put X to represent any number as well as the percentage, because you can do top 100% or you can do top 20,000. Both are potentially available. But the idea behind top is it limits the amount of return entries. It'll take the top number or percentage and then it stops. And you can set the order and all that to make sure that you pull the correct records only and that kind of stuff. That's used by order by, all of that kind of stuff. So now there's on top of top, there is top X with a left join exclusion, as well as top X with not exists exclusions. I'll go into a bit more detail on what I mean by those, but they're all very similar inside of what they do. It's just little nuances to help different use cases. So top X, it'll limit to the declared percent or numeric value. You can use the order by to organize it. And it's by itself, it's good for separation into about like 2 different groups. Like if you're doing like a 50-50 split or something like that, you can do a top like 50% or 29% or however you want to do it from that, and then order by a field, let's say subscriber ID. And then the second query would be the same thing, the top 50%, and then you'd order by subscriber ID descending instead. And the first one's ascending. And that way you get the top 50% from the original query, and then technically you get the bottom 50% on the second query. Anything beyond that, though, it gets tricky to do with just using top. And that's where we get the tops with the left join exclusions. So you can see on the left side is the original query where we get the top 20,000 ordered by new ID. And then on the right side is the left join exclusion where we go to the data extension that we are pushing everything into. We would do an exclusion on that, so it'll only pull the top 20,000 that were not already pulled. And then it'll order by new ID again to randomize it out. And then you can just continue through. And I had a target to a new data extension, which is DE2 compared to DE1, but you can push it all into a single spot if you want. Next is the not exists. And I put the wrong paste in here. I apologize. It's a literal repeat of what it was, but it's a very similar query on the second one. There is, instead of the left join, it's just a not exist, select D1 not subscriber key from the DE1, and then equals, if D dot subscriber key equals D1 not subscriber key. So basically it's just checking if that exists inside of this data extension, and the not exists, it'll put it as no. So it'll replace the left join there and then that where statement underneath of it with a not exists. Apologies again for unfortunately having the wrong query inside of that. So next is split into multiple queries using subquery staging. So breaking out subqueries into staging tables or queries, basically you take it where if you have a query that is pulling from another query, say you need to do a group by statement or something like that to get information combined together, or there's some manipulation that needs to be done prior to that top level query. There could be a query within a query, at which point breaking those out and using staging tables will help reduce the overall processing of that individual query. I think this is where I was. So yeah, break out staging queries into tables. When you run this staging DE in your final query, you may actually add time to the total run, but each of the individual query time will drop, which may get you past that 30-minute timeout. And then here's a couple quick examples. You'll see on the left side is the original one where it's got the from statement that has a select, or I'm sorry, the from that has the select statement inside of it. And then you just break it out where you have just the subquery part, and then the final pulling from that staging data extension. All right. Last is, do you need this query? Are there alternative ways to handle it? For instance, is there potentially a data leak or data warehouse or something where a lot of this processing can be done? If it's that heavy that it's going past the 30-minute timeout, there's potential that you could do it elsewhere and push it into Marketing Cloud. It'll actually be not only more efficient, but also quicker. So there's a lot of those that people tend to get stuck on the system they're using and not realize that there's tools that handle specific things better, and that utilizing them actually makes Marketing Cloud more powerful. So that's one thing I always kind of like to push out is, do you need to do this here, or is there a better approach? And then also you can see here there's approach to reduce processing. For instance, if you have this gigantic master data extension that has, like 100 fields in it and it's got like 10 million records, like, do you need all that in one place, or can you start breaking out to like relational data sets or reduce the amount of joins or columns, things like that to help make it more efficient? And then is there another activity type to help spread the processing load? So like say, can you work server-side JavaScript in to manipulate some of the data after you do the SQL query or something like that? Now, in general, I'd say this last one is probably a no, because most of the time, if it's data related, SQL is your answer as the best action. But I like to add it in there because there's always those edge cases that could come in. So next up is the workaround for script activity timeouts. So as I did with the SQL stuff, I'm going to jump into a couple quick optimizations. It's not as abundant as the SQL optimizations because a lot of it is limited in the sense of what we're allowed within the server-side JavaScript syntax context. So it's on ECMA 3, so it's very old vanilla JavaScript. But some of the quick tips and hints are, first off, limit the number of open and close of script blocks as much as possible. Each time it has a new script block, it adds a couple, I think it's near a second of processing. I'm sorry, not near a second, near about half a second of processing. Apologies. So it's as reducing that as much as possible reduces the bloat to the processing speed. Then also, and this one was actually one that very much surprised me, is the number of variables that you have. The more variables you put together and add in, so if you have like 20 different variables, that will run much heavier than if you just have, like 5 or 6. And that's because every single time that a variable is created, memory is consumed. It makes perfect sense. I just never thought about it. So the more that memory that you're using to hold variables, the less that's available to be able to process. Then obviously the clean, concise code, removing unnecessary variables, unnecessary else conditions, unnecessary returns, basically any statement that really doesn't need to be there shouldn't be there. And that'll make your code run faster. Then, of course, the efficiency of code, making sure to utilize like iterations like for loops, arrays, objects, all the functions and other native capabilities, use those in the proper places in the proper ways. So next is the script activity timeout workaround. The first one's going to go into breaking apart the retrieve aspect and the lookup part in batches to then push across. So there's pagination and batching per activity. So manually run one batch per activity. So you only get the maximum of 2,500 records per WS proxy or most of the server-side JavaScript native core functions. That is the batch that you would run through. This would retain. You would then have to put into a staging DE or something that can be pulled by the next script run. You'd have to store that somewhere so you can then have it where you have page 1 and then you see that there's a 1 inside of that DE. So on the next time it's run, it pulls page 2 and then posts into that DE that it's now on number 2 and so on, so that it continues through and each activity runs on a different batch. Unless, of course, if you're deleting the records from the source at the end of the activity, then you could just keep running it because they're no longer in there. So, if you're pulling it through to do deletions on a data extension, there's no need to put the batch number because you're going to run it on the same source, which means those records that were already deleted aren't there. And then also there is the ability to put processed value into a source per iterative record, but really, honestly, that only makes sense again if you're touching that source data extension anyway. Adding an extra update into it could potentially increase the speed and make it so that this slows down more than is necessary. But yeah, then you'd run the full activity, including the retrieval, the iteration, and the action on each of these records. This would then complete the activity. From there, it would pick up in the next activity, which is identical to this one, to do the next batch. And then there's also the time limit inside a script for multiple activities. So for this, you would utilize a server-side JavaScript timeout or time limit script around your script inside of the activity. And don't worry, I have an example in the following slide to help make a little more sense in a visual. Once server-side JavaScript do while time limit script limits out and breaks, it will upsert the numerical value, page, batch, whatever valuation you want that was last run to a data extension. And then the next time this is run, it will then pick up from the DE where it left off and continue onward. So as you may notice, this is very similar to the pagination and batch example that we just talked about. But this will allow you to maximize the number of times it's run per activity instead of a hard limit of one batch or specific number of records. Here is the visual of the time limit code. So you can put in here with the timeout is in milliseconds, which is why it's so gigantic. But you can put, say, you notice that each iteration runs at 2 minutes. You can set the time limit to be 28 minutes or 27 minutes to be safe. And that way it'll run through and hit pretty much that full 30 minutes without timing out, or as close to that 30 minutes without timing out, and iterate through so you can get as much done in that period of time as possible without worrying about running out of time. Next is separating out the retrieval part and the iteration part. So you would run one activity to retrieve the data from the retrieve or lookup call. Then you'd have this activity push to return JSON into a data extension field, not iterated through, but the actual raw JSON that's returned. And the second activity, you then retrieve the JSON from the data extension and then iterate through it. This separate, and then from there you do the action. This separates the draw of the retrieval and the draw from the iteration and processing of the data, which should then reduce the time it takes each individual activity to run. So here's a quick example of the retrieve. I was using WS Proxy here. And you'll see it pulls it out, and then at the bottom it does the upsert into my quote unquote JSON DE, where I just have an ID of 1, and then I put the full JSON inside of that field inside of the data extension. So that entire full returned JSON value is now a string inside of that DE. And then for the iteration code, we just do a lookup to that JSON DE. Looks like I messed up again on my copy and paste. That quotation next to JSON DE is supposed to be after the comma, not before it. And then that will pull the JSON field in and be a string on my JSON. And then from there, you can just parse it and push it through inside of a for loop. And that way you then iterate through the JSON and output everything. And then, as you notice, both of these kind of mention this, but there's also another way in general to do it, which is repeatable activities in one automation. So if you take the identical step and just push multiple steps inside of a single automation, say, it's going to take like 3 hours. What you do is you push 6 steps into it. So each one has around that 30 minutes to run. And then it stops and starts the next step, which is actually the same script, and goes down the line. So it does 3 hours worth of work. It's just separated into 6 blocks to get around that 30-minute processing limit or timeout limit. The next is, and this one is one I'd be careful with, hourly schedule with time limit script. So you'd have 2 activities inside of here, or 2 steps, I'm sorry, with the time limit set as close to 30 minutes as possible. And then have each of these are different steps inside of an automation that is then set to a recurring schedule for every hour. What this means is it would go activity 1 to close to 30 minutes. And then right after that, again, some time differential, because you can't hit that exact 30 minutes on these without really pushing the limits of reaching that timeout accidentally because of server processing variance and all of that. So there might be a couple minutes between activity 1 ending and activity 2 starting. And once activity 2 starts, then that runs again. And then there's that couple minutes at the end of the automation from when it started, because you now have 2 close to 30-minute activities that ran. Automation ends, and then the next hour when that hits, it starts again. So this will basically be an almost continuous real-time processing where it's constantly going back and starting over every hour. Reason I say this is dangerous, and this is something you should really pay attention to, is because of that. You're basically constantly processing something, and that could be a big draw, not only inside of automations that you're running, but your business unit, your enterprise, and even the stack. So if you're not careful, this can cause major impact to your ability to work inside of Marketing Cloud. So use with caution and only use in temporary situations. Now, to give examples, here I have the repeatable identical steps. You can see that I have the 3 steps listed out here, and it's just one step after another after another. And that would be then a single run automation at whatever schedule you want. And then the next one is the hourly schedule with the time limit script. And here you see it's just the 2, and then it's repeat every hour, and it'll just keep continually loop back calling itself. There was a big push to have where you'd have two automations that keep calling themselves and they would be identical, other than the last step would be a script to then call the second automation, and then the second automation at the end has a script to call the first automation. And that is valid. That is something you can do. I just find that calling aspect at the end, that script, first off, it's an API call that if they ever get to where they keep track of those and limit you and charge you for it. I know that's coming down the line. It's already started where they're controlling and using that to measure, but I don't know when the full implementation will come out, similar to it is in a lot of the core platforms. But that's a whole bunch of extra API calls. And not only that, it opens that if something happens and that script just doesn't run right, or it calls the automation, but the automation was still running or something, that it could not actually run it. And then all of a sudden your recurring automation no longer is recurring. It just randomly stopped and there was no error. So you don't know. So I tend to try to use this hourly one where it's repeating itself instead, because if that ever stops, you'll get the notification that you set up that something failed. Whereas the other, there's some holes, and then you might need a recurring automation to make sure your recurring automations are running. And yeah, it becomes a lot. So I find this one to be a better option in those cases. But again, use with caution, only temporarily. Don't leave this running forever. All right, alternatives to a script activity. So if you're still coming down and you're just like this seems like too much. Like I've split it up. I've got it now. It's like 50 different steps. This is crazy. Like it's still timing out. So that's when you check, for instance, if it's data oriented, could this instead be a SQL query, or partially a SQL query, or mostly done as SQL? Can this be done externally? Is this something you can process inside of like a middleware app, or inside of a different system that's more made for this type of scripting, and then just push through API or a connection and push the data or whatever content you need into Marketing Cloud already completed? Is this something that should be handled through, like, say, extracts or other tool sets inside of Marketing Cloud? Sometimes when you're trying to pull data out, like for instance, you could be hitting the sent SOAP object and you're trying to get all of the sent data that way. And it works great on small, but as soon as you start pulling from like a high output enterprise or something like that, it's falling over because of the timeout, because it's such a large volume. At that point, you might look at going to like a tracking extract to pull that information out, and it comes through. It's now inside of a CSV file instead, but you can then utilize that, and that's pulled where it won't have the same issues that you might run into with those scripts. And then also, could this be accomplished outside Marketing Cloud? So one good thing with this is you could have it where it uses the APIs to interact, and like say like that tracking data stuff, you can have it running from that data lake that's trying to pull all that tracking data in, and use API calls to gather the information through that data lake instead, and remove the processing from Marketing Cloud in general. Which ties into the conclusion. There are some capabilities to work around the time limit or hack around it, but that is not always the preferred method. Making your scripts and queries smarter, more efficient, and performant is the preferred method. Anything that still does not fit within the timeout window, you'll want to look at the process and see if there is a better way to handle this to best utilize the appropriate tools for the appropriate actions. And I know that seems counterproductive to the fact that I just went over all of these great ways to try and get around that timeout limit, but I wanted to notate that yes, there are these great ways to get around that if you need to, but only do it if you need to. Try to limit the amount of times you do that, because it can have an impact on a lot of your other processes and such that are going on. On that note, thank you, everyone. I believe we can open it for questions.
Hey, Greg, I see
What
a
about
couple of questions I can read out to you. One is, will this data retrieval server-side JavaScript code work for data extensions having around 700 million records with the timeout code?
Yes, in theory, but I would say with 700 million records in your data extension, you should probably look to shift that out and put some sort of retention on that, because I've noticed that once you get close to that billion record one, the data extension starts to become completely unusable. The system itself won't interact with it at all, to the point where I've had it on a client. I can't extract the data extension that has, I think it was like 1.2 billion records on it. There was a said log they didn't put any retention on. I can't even extract it and get the data out to then archive it so that I can cut it down. So I would worry more about trying to reduce those records where possible first. But yes, the code will work. It's going to be slow, so I mean you're probably going to be looking at hundreds and hundreds and hundreds of steps and activities to do it. But it's it's a bit rough to do with that high of volume. Again, that's Marketing Cloud isn't made to handle that kind of numbers to interact within the ETL aspect. So being able to utilize a database system instead would probably be your best bet. I know that's not always the case. There's not every company can afford to have a database software, or even be able to have those interactions and have a developer be able to connect it and all that. So I do get it and I do understand, but I think that even if it's pulling it out in relational data sets or something to reduce the overall bulk of that data extension would be drastically helpful.
Okay, thank you for that. Earlier we had a question. There's some responses in the chat. I think it would be really good to also hear your feedback. What is the best
Sure.
practice for selecting fields in SQL when working with large tables? Should we use the wildcard to select all fields, or explicitly specify the fields we want to select and why?
So
And again, like
best
I know there's been
practice.
conversations in this, but I think we'd love to all hear like your thoughts on that.
Thank you. Yeah, that best practice I would say is to push out every single one of those. Now, that being said, I rarely do that. But the consideration to have on that is that using the wildcard, when you do that in Marketing Cloud, if you change any of the fields, say in the data extension, and you have it where you delete a field and then add, two more fields to it, until you go and actually update that query, it is actually cached to pull those specific fields that were in that data extension where it was saved. So say before you create the query, you have my primary key, my field 1, my field 2, my field 3, and then you go create the query with the wildcard, save it. Then you go, oh crap, I forgot my field 4, my field 5. You put it in that data extension and save it, but you don't touch the query. And the query is filling data extension 2 that has all the same fields, including 4 and 5. But you notice 4 and 5 aren't filling. What's going on? Why isn't this working? You have to go into the query and actually make a small minor change and save it again, and then it'll actually recognize those, and it'll pull the current fields inside of that data extension instead of the original cached one. So there's little nuances like that to be considered. As to performance wise, honestly, I haven't seen a major difference. I'm sure there's plenty of people that would stand up and say that's not true, and wildcard is less performant, this, that, and the other thing. But at the level of data we're looking at instead of Marketing Cloud, I don't see a major impact to doing that, other than just the preference and being able to view the fields and the customization, and then dealing with those little nuances, like I said.
Thank you for that. And again, guys, we have Greg Gifford with us on the line. So if you have any questions for him, please feel free to post them in the chat. I did see a couple questions about the recording. So yes, we will be sharing the recording out. Somebody asked, just wondering if we have 2 master data extensions, so how will the query change?
So that depends on how you want to connect those 2 master data extensions. There's the possibility you can create a staging data extension between the 2, where you make your initial connections to get the initial records, and then you pull different queries to fill in the rest. There is possibility of having that join if it's not too significantly large, that you can have that join in a subquery or something along those lines. It's really dependent on the relationship between the 2 and how that interacts with what your purpose is in the context of the query.
Thank you.
Yeah, it's not a full answer, and I apologize, but that's really the best advice I can give from that.
No, and we appreciate it. One more question just came in. Let's say if we want to create composite key or multiple primary keys in a data extension, and one of the field for primary key is data field. So is it a good practice to use data field as the primary key column?
So I would say no, but that's my personal opinion. I honestly don't have a lot of data to back that up. To be fair, I haven't put the research and investment to really definitively say anything as absolute. Me personally, I hate using date as a primary key because it goes down to like milliseconds. So it's a very unique number or value, I guess. So it's, in order to match it, you then have to either manipulate the primary key into a date only, which then changes the primary key into a completely different value, or you have to, anytime you want to match on it, you have to go down to the millisecond on the date to match it. So it's not necessarily that there's an issue with it being a primary key to the processing or value. It's more of it's a pain in the butt to match and use that as a foreign key in connection to other areas.
Thank you for that response. I don't think we have any additional questions coming up. The session was very informative. I know JB is having some audio issues on her side. So JB, I wasn't sure if you had anything else you wanted to conclude with. So Greg, I would like to thank you on behalf of JB and the community for doing this session. It was very informative. And as I mentioned earlier, we will post the recording in the in the YouTube page, Trailblazing Together. So please go there for recording of the session. And if anybody has any questions, you will be able to find Greg on LinkedIn, on Twitter, and in the Slack channel. So thank you everyone for joining. Enjoy the rest of your day. Thanks, Greg.
Thank you.
Thanks,
Just
JB.
one quick note.
Yes.
One quick note. I am no longer looking at my Twitter.
Oh.
And that has become a bad thing. So if you hit me up there, I probably will not respond.
You could hit me up and then I'll find Greg. All right. Thank you, everyone. Enjoy your day.
Thank you.